Good morning, dear students. How are you today? Today we are going to have lesson 2, symmetry of coordinate plane. Remember that opposite numbers are the same distance from 0 and on the number line. They are in the opposite directions. Opposite numbers on the coordinate plane have symmetry, as we have said in lesson 1. When the coordinates of 2 points differ only by the sign of the x-coordinate, the points are symmetric with respect to two y-axes. One point is a reflection of the other point across y-axis. We will see this now here. When the coordinates of 2 points differ only by the sign of the y-coordinate, the points are symmetric with respect to the x-axis. One point is a reflection of the other point across the x-axis. When the coordinates of 2 points differ only by the signs of both coordinates, then one point is a reflection of the other point, first across the x-axis, then across the other axis. Okay, here example, we want to know this by using examples. The coordinate plane here shows a point A and point B. Shows point A and point B. What are the coordinates of point A after a reflection across the y-axis? What are the coordinates of B after a reflection of the x-axis? Okay, I have here point A, -3 and 6. Okay, and here after reflection reflection across the y-axis, it will be 3 and 6. Okay, the same distance with what? With difference in the sign of what? Of x-axis, because here 3 is in the x-axis, so 3 here differs from here with the sign which is here negative, and here it changes to the positive. So point A, -3 and 6, and 3, 6, point B are symmetric with respect to the y-axis. The x-coordinates are opposite here. Focus with me here, open your eyes. Okay, it's very good and cool and very easy too. I have here x and y. Okay, x and y. X here and y, this point, the ordered pair is called what? Is called A. A reflected to the other side. Okay, how do it reflects? I changed only the sign of the x-axis. I changed the sign of x-axis. Okay, it reflected. It's called here reflected. But the y-axis is the same, symmetric. Okay, like I say, same, symmetric. So this is the reflection of point A. Here, point B, which is 5 and 4. 5 and 4. Okay, it reflected here and become 5, -4. 5, -4. So what did change here? Okay, what changed here? I have point B, 5 and 4, and 5, -4. Here the x-axis remains the same, symmetric, right? Okay, but 4 has changed the signs, so 4 will be -4. They are symmetric with respect to the x-axis. Okay, the x-coordinates are the same, the y-coordinates are opposite. The y-coordinates are opposite. Okay, it's easy now. Okay, the coordinates of point A after a reflection across the y-axis are 3 and 6. The coordinates of B after reflection across the x-axis is 5 and -4. I think it's very clear now. Okay, here Find the coordinates of each point after a reflection across the x-axis. X-axis. So here the x-axis will remain the same. Okay, x-axis will remain the same. But what changes here? The y-axis. It will change to its opposite. So negative 13, the x-axis will be the same. Okay, the reflection will be across the x-axis, and the y-axis will change, will be the opposite, negative 13. The opposite of negative 13 is 13. Here I have in number 2, also the x-axis will remain the same, and the y-axis will change to the opposite of negative 4, will be 4. Here in number 3, negative 10.7 will be the same, negative 10.7, and we will change the y-axis. Okay, here negative, it changes to negative 9.3. Find the coordinates of each point after a reflection across the y-axis. Okay, here I have here 4 and 8. So here the x-axis will change. The point x will change, sorry. So 4, the opposite of it will be negative 4, and 8 remains the same, and so on. Here I have what? Find the coordinates of each point after a reflection, first across the x-axis and then across the y-axis. So I will change both of them. Negative 8, I will do the opposite of it. It will be 8. Negative 8 will be 8. Negative 9.7 will be 9.7. 7.1, the opposite of it will be negative 7.1, and so on. Okay, change the sign. Okay, here he asks me to know that point Q is in quadrant 3. I start with the right, 1, 2, 3. Okay, assume here point Q is reflected across the y-axis to point P. Which quadrant will point P be in? Okay, if it make reflection, so where is point B? When it goes to quadrant, to the quadrant that passes the y-axis. This is the y-axis, and the point is here Q. I want it to pass y-axis. Okay, so it will reflect from here, so it will be in quadrant 4, right? Okay, look this one, it's very interesting. Point G is in quadrant 1. This is quadrant 1 in the right. Okay, point G is reflected across the x-axis. Wow, reflected across x-axis. This is the x-axis, so it reflected across the x-axis. Okay, here, and then across the y-axis. So it was here, and then go across the x-axis. Okay, it passes the x-axis and got here, then across the y-axis. This is the y-axis, this across the y-axis, so it's here now. Okay, here, look with me here in quadrant 4. No, it's not quadrant 4. Let's count with each other. 1, quadrant 1, 2, 3 and 4. 1, 2, 3 and 4. It reached now what? Quadrant 3. So which point could be possible coordinates for point H? H must be what? Here I have negative and here I have negative. So it must have two negatives in X and Y. So this is no, this one no, this one negative and negative. So this is the answer. It's very interesting. Yeah? Okay. So here in the practice book, use the coordinate plane for problems 1 to 3. Okay, what are the coordinates for a point that is a reflection of point A across the y-axis to pass here the y-axis? So it will be, I have here what? The same distance. Okay, it will reflect with the same distance. Okay, and this will be in the same distance 1 2 3, 1 2 3. Here the reflection will be here, so it will be what? 3 and 4, 3 and 4 with positive signs. Okay, it was -3 and 4, then it reflected to be 3 and 4. What are the coordinates for a point that is a reflection of A across the x-axis? So what should I do? It will cross the x-axis. It's very easy. So it will cross here. How many here square units? 1 2 3 and 4. So I will move 1 2 3 and 4. Here is the point of A, the same distance. So what is this, miss? It will be, this point is -4, right? -4, excuse me, -3. I moved here 3. Yes, -3, -4. I start with the x-axis here, 1 2 3. So I start reading by reading the x-axis, -3, and then go down until I get to -4. So it will be -3, -4. Okay? In which quadrant is a point that's a reflection of point A across both the x-axis and the y-axis? Okay, it's very easy. It will pass the x-axis and then the y-axis. When A passes through x-axis to go like this, and then passes through the y-axis, it goes like this. So it will be in the 4th quadrant here. I want you to count with me the quadrants: 1 2 3 and 4. Find the coordinate of each point after a reflection across the x-axis. As I told you before, here x will be the same and just y will differ. Differ in what? Differs in the sign. The opposite of -18 will be 18. And this one, as I told you before, here the coordinates of point after the reflection across y-axis. So x here will change from 5 to -5, and 10, the y-axis remains the same. Find the coordinates of each point, excuse me, after a reflection, first across the x-axis and then the y-axis. Change the signs of both of them. Negative will be positive and positive will be negative for both of them. -5 will be 5, -5 will be 5. -10.8 will be 10.8. Positive 8.1 will be -8.1. Okay, dear students, study well from the PowerPoint presentation, the YouTube presentations, the worksheets. Solve your homeworks and send them on Google Classroom. And if you have any questions, please send them on Google Classroom. Thank you for listening.